Hello everyone, welcome to IDTechEx webinar on humanoid robots, early adopters, technologies, challenges, and outlook. My name is Yulin Wang, and I work as a senior technology analyst from IDTechEx. Over the next 20 minutes, I'll be introducing the key technologies of humanoid robotics, target application areas, commercial and technical challenges, as well as the potential opportunities for humanoid robotics. So before getting into the main content of today's webinar, let me just introduce who IDTechEx is and what IDTechEx does. So the company was founded in 1999, and since then we have provided independent market research, consultancy, and subscriptions on emerging technologies to clients in over 80 countries. So we cover a wide range of topics, including 3D printing, food and agriculture technology, healthcare, 5G, 6G, RFID, robotics, semiconductors, sustainability, wearable technologies, and many others. So through our research, we conducted technology assessment, technology scouting, company profiling, and we also provide market sizing, market forecasts, as well as strategic advice. So one thing I would like to highlight here is our subscription platform. So by subscribing to IDTechEx platform, you have access to a variety of information, including the research reports, company profiles of different companies, ranging from small startups all the way to multi-billion conglomerates. You can understand, their technologies, their business models, and our independent analysis of different products of those companies. You also have access to technology analysis, forecasts, event highlights, research summaries, company slideshows, as well as analyst access time, briefings, and strategic advisory sessions. So for more details, please feel free to click the link bottom left, www.idtechx.com/subscriptions. So now let's come back to humanoid robotics. This is the agenda for today's presentation. We're going to begin by exploring the emerging landscape of humanoid robotics over the next decade, from 2025 through 2035. So essentially, humanoid robotics are expected to disrupt several industries, with automotive and logistics identified as two primary early adopters. So these sectors have a high demand for repetitive, structured physical tasks that humanoids are increasingly capable of performing. So the market outlook is very promising. We're looking at a 10-year forecast, not only for overall humanoid deployment, but also for the individual components that power them, such as batteries, actuators, motors, screws, sensors, and many others. So these components will define robots' capability, costs, and the reliability, and therefore the key to scaling adoption. So what makes humanoid robotics particularly appealing is their human-like form factor, which allows them to operate in environments already designed for people. So this just really reduces the need to redesign the factories or warehouses, making deployment more flexible and cost-effective. So of course, adoption won't be without obstacles. We'll also examine the regulatory hurdles, commercial viabilities, and technical challenges in the following slides, including energy efficiency, coordination, durability. But we'll also look at the timeline of key players, emerging business models, and technological breakthroughs that are accelerating the path to commercialization. And by the end of this webinar, you will understand where humanoid robotics are headed, what's technically possible today, and what to expect in terms of market dynamics and the growth potential over the next 10 years. So all the content that I'll be presenting for today's webinar are from IDTechEx's latest research on humanoid robotics 2025 to 2035, as you can see on the left-hand side. So if you are interested in anything or further details, please feel free to check out this website. And there are also sample pages available for you to download for free. So now let's dive into humanoid robotics a little bit more. So as we mentioned just now, humanoid robots are essentially just robots that look like human beings. So this slide shows the capabilities of current generation humanoid robots using a side-by-side comparison of weight, payload capacity per arm, and the operational time, which are represented by the bubble size in this chart. So the horizontal axis shows the robot weight in kilogram, and the vertical axis represents payload per arm, which is a critical indicator of what tasks a robot can physically perform. For example, heavier payload are essential for lifting parts in an assembly line or moving packages in a warehouse. So we can see a distinct clustering of robots designed for industrial applications, which are labeled in blue. For example, those from Boston Dynamics, Sector AI, Kepler Robotics, and Apatronic, and also Tesla, Figure, Agility Robotics. So essentially, these systems often weigh between 60 to over 120 kilograms, and they can lift more than 20 kilograms per arm, with operation times up to, let's say, 6 to 8 hours. So this positions them very well for logistics, automotive assembly, as well as warehouse automation. In contrast, we also have quite a few robots that are designed for non-industrial applications, which are labeled in yellow. So examples include Unitray and PromeBot. So essentially, they are lighter and less powerful, and they have shorter battery life. So these robots are often used in service, research, or education, where physical demands are lower and the mobility is more important than strength. And also, from what you can see here is that there are several outliers. So for example, 1X and Westwood Robotics. So they offer relatively high payload capability at a much lower weight, suggesting a unique engineering approaches or novel use cases, possibly in mobile or human interactive environments. So one thing I'd like to highlight from here is that there is always a performance trade-off at play, for humanoid robotics. So essentially, a higher payload generally requires a heavier robot with more powerful actuators, and the longer operational time typically demands better battery technology and energy management. But essentially, hopefully, this chart highlights how robot form factors and specs are closely tied to their target use cases, and why not all humanoids are designed for the same environments. So this chart gives us a time-based view of how different applications of humanoid robots are progressing through commercial adoption curve from niche market to saturating market. And we have broken it down into 4 primary sectors, including automotive industry in purple, logistics industry in red, security in green, and the domestic applications in pink. So now we're going to start with the automotive industry first, which is already seeing traction in use cases like beige labeling and inspection, quality inspection, and simple material handling. So these tasks are often repetitive and require precision, which is ideal for humanoids, and within the next 5 years, these applications are expected to move from relatively niche or growing market to the mainstream, with potential broader deployment in the following 5 years. And then moving down to the logistics sector, use cases like a trailer unloading or packing and intralogistics. So these applications are following a similar path with several pilots already underway. So these robots must handle heavier payloads and function in semi-structured environments like warehouses. And we also believe that widespread adoption will happen within a decade. Whereas in security, robots used for patrolling or surveillance are transitioning into a growing market phase. So these don't really require heavy lifting, but they do demand autonomous navigation, obstacle avoidance, and in some cases, physical or object recognition. So the market here is expected to expand over the next 5 to 10 years, particularly for indoor environments like hospitals, campuses, malls, tube stations, etc. And moving down to the next one, which is the domestic use. So domestic application is probably the most ambitious, but also the most challenging area at the moment. So tasks like elderly care or household chores and meal preparations are extremely complex due to unstructured environments, variability in daily tasks, and high expectations for safety and interactions. So these are currently early stage applications and are unlikely to mature before 10 to 15 years because they depend heavily on breakthroughs in artificial intelligence, human-robot interaction, and the energy efficiency. What is very important for this particular applications is that there are quite a few regulatory concerns. Therefore, IDTechEx expects that they wouldn't really take off until they see a lot of successful examples being validated for humanoids in more industrial settings such as warehouses and factories. So a key takeaway here is that indoor environments with controlled lighting, temperature, and predictable layouts are very likely where humanoids will prove their value in the first place. And that is why automotive industry and the logistics will likely lead the change in the near term, with other sectors to follow as the technology matures and the cost barriers decrease. We're going to dive into a little bit more on humanoid robotics in the automotive industry in this chapter. So let's take a look at the current trajectory of humanoid robot deployment in the automotive industry. And here we specifically focus on BYD and Tesla because they are two companies pushing hard into this frontier. So in 2023, the key players were firmly in the research and development phase, and there was almost no commercial adoption of humanoid robots to IDTechEx best knowledge. So companies were still deep in prototyping and testing, and the focus was on development rather than deployment. By 2024, the landscape began to shift a little bit. A lot of key players were entering the small volume deployment phase. For example, BYD has planned to have 150 humanoids in place by the end of 2024, which IDTechEx believe that they have achieved that goal. And many major automotive OEMs, for example, Mercedes-Benz, BMW, and NIO, so they're also deploying humanoids, but in 2024, the volume of deployment was only in very limited numbers, often in the single or low double digit. However, Tesla at that stage has only deployed a few dozen in 2024. So one of the major barriers during this particular phase is the cost. The average selling price of humanoid robots remain very high, making meaningful commercial deployment pretty challenging. So according to IDTechEx analysis based on Tesla's Optimus bill of material, Tesla's Optimus can possibly cost over $100,000. Meanwhile, BYD's estimated bill of materials based on UBTEX units is around $25,000 US. And now moving down to 2025, IDTechEx expects significant acceleration. BYD aims to deploy 1,500 humanoids in 2025, which is this year, and the Tesla's goal is somewhere between 5,000 and 10,000 Although Elon Musk himself had suggested that deploying 5,000 would already be a success. However, IDTechEx believes that Tesla will more realistically deliver around 1,000 to 2,000 units, which likely will align closely with BYD's scale. And importantly, 2025 is widely considered as the year when the industry expects to see a decrease in average selling price. So BYD is targeting $20,000 per unit for those 1,500 humanoids, and the Tesla's costs are also expected to decline, with IDTechEx estimating Optimus could be brought down to around 80,000 as production scales up. And then moving down to next year in 2026, we anticipate a phase of relatively bulk adoption, at least among the leading players. So BYD is targeting 20,000 units that year, and the Tesla's goal is even more ambitious, so somewhere between 50,000 and 100,000 units in 2026. So if production ramps up as planned, then the average selling price will continue to fall. And according to BYD, they're aiming for a cost of just 15,000 per unit, and Tesla's price target is around 20,000 per unit, although that might still be out of reach in 2026. So overall, the market trajectory is moving very fast, from isolated pilots in 2023 to potential mass adoption within 3 years. So the automotive sector, with its massive operational scale, could be the proving ground for humanoid robots, turning a kind of like a futuristic concept into an industrial reality. And now we're going to dive into a little bit on the technical and manufacturing challenges of humanoid robots. So the automotive manufacturing as well as the logistics sectors represent two primary targets for high-performance humanoid robots, with several leading models demonstrating capabilities suitable for factory deployment. This slide only compares the humanoid's batteries, which is one of the most important components for humanoids. However, humanoids also have many other components, including sensors, screws, motors, and many others. So if you are interested in more details, all of those components have been analyzed thoroughly in IDTechEx report on humanoid robotics 2025 to 2035, so feel free to check it out. But here, if we look at our battery performance data, and then we can identify a distinct pattern among humanoid robots designed specifically for industrial applications. So the Tesla's Optimus and the Figure models, which you can see here, so they cluster in the upper right of our analysis, featuring both impressive battery capacity exceeding 2 kilowatt-hour and an operational time approaching, somewhere between 5 to 6 hours. So this performance profile makes them particularly well suited for automotive production environments where sustained operation is essential. What differentiates these automotive-focused models is their superior power efficiency ratio, which is the relationship between battery capacity and operating time. So these industrial humanoids achieve a ratio between 0.15 in full power mode, and it can extend to 0.56 in standby configurations. So this efficiency enables longer production line integration without frequent recharging interruptions. Kepler's robot can even extend this boundary a little further, with operational times extending to nearly 8 hours while maintaining high battery capacity. So this extended runtime represents a critical advancement for automotive manufacturing applications where production continuity directly impacts assembly line efficiency. So when we examine the constraints of typical consumer or research-oriented humanoids like a Unitray or Fourier, we see substantially limited operational windows. They are typically under 2 hours at full capacity. So such limitations make these models impractical for industrial settings like the automotive manufacturing environments, which require sustained operation across the entire production shifts. So the automotive industry's gravitation towards models like Tesla's Optimus is primarily driven by this performance differentiation. So factory implementation demands robots that can operate continuously under high torque conditions while manipulating components and performing precision assembly tasks. So beyond raw performance metrics, these industrial-focused humanoids also incorporate fast charging capabilities and hot swappable battery systems. So for example, Agility Robotics offers swappable batteries, which further enhances their practicality in manufacturing settings. So this also allows for minimum downtime between shifts and maximizes productive implementation hours. And then we'll dive into the commercial and regulatory challenges. So in addition to technical challenges, humanoids are a still relatively new concept. Therefore, they also face regulatory and commercial challenges. So the first regulatory challenge is the safety standard. If humanoids are going to work shoulder by shoulder with human operators, then they need to meet strict safety rules, and the current standards are still evolving. And there are also some certification delays because it takes time to test humanoids' stability and reliability. So this will lead to a delay in certifying process. And then workforce impact rules. So some of the laws might require retaining programs to offset job loss from those robots. So this makes people wonder, is it really necessary to introduce a lot of humanoids if they still have to employ human workers? So those are from the regulatory perspective, and many of the regulatory challenges also map into the commercial challenges. One of them is the high initial cost. So at the moment, because the volume is still pretty low, so the capital cost is quite high. As we mentioned on the previous slide, for Tesla's Optimus, we're looking at 6 figures, which is a very high initial cost for automotive industries. And then the return on investment uncertainty. So this is also partially because of the high initial cost, and also people are unsure whether they are able to replace human workers and whether they can really make the money back by deploying humanoid robotics. And then market competition. So there are also a lot of competitors, for example, like traditional industrial robotic arms or collaborative robotic arms or mobile platforms. So they are pretty mature technologies, and compared with humanoids, they have a lower cost. So that makes people wonder, why do they have to use humanoids? They might just choose more mature and established technologies over humanoids. And finally, testing limits. So robots must match human performance in detailed tasks, and at the moment, very few can currently meet the 90% of success benchmark. So this means that the technology is not quite there, which ultimately, is a commercial challenge that hinders people to adopt more humanoids. And finally, we're going to wrap up the presentation by a quick market forecast and summary. So despite the challenges mentioned above, we believe that the humanoid robot market is still going to explode, and this is primarily driven by the commitment and the initiatives of those leading players like Tesla, BYD, and many others. So IDTechEx projects a 29 billion market by 2035, and we are standing at the start of the line of a technology revolution, really. So the automotive sector is leading this charge, while most OEMs are currently in early pilot testing. Industry leaders are scaling up 10 times year over year. So by 2027 to 2028, we will see humanoid robots performing specific tasks in automotive manufacturing environments. So this growth isn't just about the robots themselves. If you look at the component market projections, for example, like motors, sensors, batteries, LiDAR systems, so these components are also seeing parallel growth trajectories. Component costs are expected to fall drastically as production scales, particularly for mechanical elements like roller screws. And the logistics and the warehousing sector shows promising adoption patterns as well. Although automotive applications are clearly dominating market share through 2035, and then we believe that logistics will quickly catch up, and there is also a substantial market in the logistics and warehousing industry. So to summarize a little bit, we are experiencing the takeoff year right now in 2025, and the companies positioning themselves in these ecosystems, whether in full robot development or critical component manufacturing, are expected to capture significant value in what will become a multi-billion-dollar industry. So we do believe that this industry has a massive potential. And if you are interested in more details on different components and the technical challenges and the humanoid and detailed trend, please refer to IDTechEx Humanoid Robotics 2025 to 2035 Technologies, Markets, and Opportunities. So to summarize, this is our webinar for today, and all of the content are based off IDTechEx research on humanoid robotics 2025 to 2035. Again, feel free to check out, and there are sample pages available for download. So if you are interested, you can get a download, and this is completely free. With that, it comes to the end of my presentation, and I hope you have enjoyed it. But if you do have any further questions, please feel free to get in touch via email, research@idtechex.com, and I'll be happy to support and have a discussion. Thank you very much, and have a good day. Bye.